Okay, so substitution is a method to solve integrals. Some people call it the reverse chain rule. Okay. So we're going to start with the derivative that requires the chain rule, and then I'm going to build it backwards just to kind of give you an idea of where this is headed and the relationships involved. What's the derivative of sine x squared? Times? Okay. So what does that mean, the integral of 2x cosine x squared is? And then don't forget that beautiful constant, because it's not a definite integral, right? So the question would be, how can I solve this without knowing what the original function is? You can. Okay. Tell me, is there a relationship between x squared and 2x in calculus? Yeah, it's the derivative, right? So what you end up with is some function inside. Oh, busted. I didn't write it.
Oh my God. Uh-oh.
And the derivative. Okay, so if you can have a function with its derivative in there, it makes the integral possible. So tell me, is this possible?
I have no idea.
What's the derivative of this function?
Oh,
Does it occur here?
whoa.
Yay, doable.
Whoa.
Okay. The integral is going to be cosine x plus x cubed plus c. Okay.
Cosine?
Sine, negatives. Sorry. Why do I do that all the time, don't I?
So how did you, so you find,
So it's this, you have this function. The derivative of it occurs out here.
okay,
So it's, if you take the derivative of this, so you have the derivative of the inside, it becomes that,
okay,
and the derivative of the outside is right here. It's the reverse chain rule, okay? So what we gotta do,
Go back to plus C.
so for some people, this reasoning works for some people, okay? For others, like, that are a little bit more mathematical, it makes it a little easier if there's some structure, okay? So this is called U substitution.
it's called what?
U substitution, yeah. And I'm going to show you with the original. If you say it's horrible, it's going to be horrible. So stop it. Okay, good. Okay, this, we know what the answer is. Yeah? I'm going to show you how to do it with this methodology. Use substitution. Okay, you know that this is the function, that's the derivative, correct? Okay, so this is going to be u.
Oh my God.
So right now you have cosine of u, right?
Mhm.
What is the derivative of that? 2x. Okay.
Oh, do you here?
Derivative of u with respect to x. Okay. Here's where a lot of people get stuck. I move the dx to the right side. You can't perfectly mathematically say it's multiplied by each side, but that's kind of the general idea. So this right here gets rid of this and this, right? And replaces it with du. This is where it gets confusing.
That's not as bad as last year.
Okay, this, see these two right here?
Oh, yeah.
That's 2x dx, correct?
Oh. I didn't say so.
I'm replacing it with du.
So then you can say cosine x squared du.
No, cosine u du.
Cosine du.
Because the u
U.
is right here.
Oh.
So now, is that right there, is that doable? What's the derivative of cosine? Or, sorry, the integral. Yeah. Sine of u, right? Plus c. And now just plug x squared back in.
What are we doing with the D? Oh, we don't need to do
It's part of the integral. When you calculate the integral, it goes bye-bye.
I gotta do plus C again, huh?
Right.
And then once you have cosine u du, you find the derivative of it?
No, you take the integral, see? It's an integral. Yeah. So the integral of cosine u is sine u, and then plug x squared back in for u. Okay. Let's try another one. Last year it sucked.
Okay.
All right, so this, what's the derivative? 2x. So we have something close to that here, right? The x is what matters. So this is u. Okay. Yep. So now, right now, we have u to the 5th, right? Because I've substituted here and here.
What about that X up front?
We're going to get to it.
Oh, yeah, you're gonna get an X dx.
Take the derivative.
I feel you.
Wow. You did the 6. Oh my goodness.
Okay, so we put a u in here. This is my new integral.
So we're gonna put a 2 on front.
Okay. Here,
Where did you get? Oh, the derivative of that.
yeah, the derivative is 2x. Now take the dx over. Now, is there a 2 in the original? No. So I actually have to move it to the left side by division. All right, so what I end up with is 1/2 du equals x dx. Now I got this
Yeah.
here, right? X dx gets replaced with
1/2 you.
this guy right there. Now, what's the integral?
1/5 u to the 6th over 6.
The 1/2 stays the same. Yeah, where's my black pen? 1/2, right? Constant stays there. Add. It's just a power rule now because you just have a u. Now substitute u back in. Okay, so we get x squared plus 9 to the 6th over 12 plus c. And that is your answer.
How did you get to 6?
You add, remember, integral power rule, add 1 to the power, exponent, and divide by it.
That's
Right. Shall we do another one?
That's all we got to do.
You just gotta keep doing it.
Let's do some homework one together.
No, those are for your practice.
Yeah. Well, Ben,
So,
why would you suggest that? Look at that camera.
Okay, and we're just throwing situations at you for you to use the same method. X squared plus 2x over x cubed plus 3x squared plus 12 to the 6th.
The bottom's in the U.
Yeah, so notice x cubed has a derivative that's x squared, right? So u equals so right now we have u to the 6th on the bottom. Now take the derivative there. And some people can just do it like that with skipping that du dx step is fine, if you're okay with that.
what did you? Oh, I see what you did.
I just skipped a step.
Okay.
Maybe you don't want to, maybe you do, it doesn't matter.
I see what you did.
What the dx be times the 3x squared plus 6x, wouldn't that be a divide by 3.
You can put it in the parentheses. Okay. Now, does it match?
No.
No, we got to take a 3 out, factor it, right? Okay. They still don't match, so we have to take this 3 out by division, and you get 1/3 du equals x squared plus 2x
dx. Now we're matching. Right, those two match. We're going to replace it with that. 1/3 du. Still there? Hanging with? Okay. Make that a power rule problem by, if you want, you can move the third out front. Some people find it easier.
So tell me if you're on the same page here. 3 u to the -5 over -5.
1/3.
At the integral. Yeah, okay, up there where you got the bright ink, could you just put so that it was 3 u to the -6? Oh, that's what you did.
No.
What do you mean? You can't have like 3 u to the -6 on that side. The 3 is not to the 6 power.
You'd have to have 3 to the negative first.
Okay.
With u to the -6. Leave it a fraction. Don't confuse yourself. Okay, so here's the derivative. Is that right? I added 1 and divided by it. So 1 over -15 u to the 5th. Put your u back in. And all of a sudden that really complicated integral is solved. Okay.
Is it though?
Oh, goodness.
All right. I want to show you one more, and then I'll let you start. Tomorrow I'll show you a few more, okay? A deal?
5.6 is due tomorrow. 5.6a. 5.6a is due tomorrow.
We do want to check it. I want to check it tomorrow.
This homework?
Yeah, the first part of it. I'll write it down for you. But. See, last year we had so many problems with this that I need to check. I think you're good, but I want to check to make sure. So that's what we're going to do.
Are we in a class when you're working on it tomorrow?
Yeah.
Is that 7 theta?
Yeah, so the integral of sine 7 theta plus 5 d theta.
Wait a minute. We have class on like all class on.
No. Just a lot, Ben.
Is it going, it's 5.6a going in third grade?
Yes.
At the end of class.
Okay. Well, let's finish this problem. You guys can already do this based on one of the formulas I gave you. But we can also do it using U substitution. What am I going to set U equal to? If you can do this, go ahead.
Where would it, don't you have to have the derivative in it? Like when you have the.
What's the derivative of that?
Where's,
Is there a 7 out here anywhere? No, so we're going to divide it out. Now, d theta gets replaced by this.
then how do you determine stuff like that? What section is going to be you?
Because you're looking for the item that has a derivative outside here. So the derivative of theta is 1, right? So it's out there.
Oh,
You just need to mess with the constant to make it work. And then you can take your derivative, which is
Can it be negative cosine u?
not yet, because we still have the integral here.
Oh, yeah, you have
So when you do the integral,
never mind.
yes, now you have the negative 1/7 cosine u, which is right there.
du. Oh, yeah.
Here? Is that what you're talking about? That is u, so I just put it in.
Oh.
So we set u equal to that. All right. I think you have a basic handle on it. Tomorrow I'm going to show you more, but I want tonight this. The A needs to be done because we're going to check it tomorrow. If you want to start, okay, that's the entire assignment, but this we'll check tomorrow. The rest of it's not due until Tuesday.
Are you reading that without the topic?
We're just going to check in and see where you're at. Okay. There'll be a responsibility score because there are no evens, right? Do you have any questions I can answer? Okay.